everyone. I say good morning because it's about 7 a.m. here. I'm David Tischler. I'm a developer advocate at Balena, and I'm coming to you from Phoenix, Arizona. So I'm still working on my coffee here. Um, but I'm happy to be here. Let me get my screen share up and running. Let's see if this works. And if everything goes according to plans, you should see some slides. Pierre, I see you in chat. Hello. All right, thanks. Now I can no longer see myself. I don't know if you can still see me or not, or only the slides, but either way, let's get going. Only slides. Yeah, well, thanks, Pierre. All right, well, you know what? I'll kind of flip back and forth throughout the presentation then. So, as I mentioned, my name is David, and I am a developer advocate at Balena, and I'm excited to talk about some of our open source projects and open source efforts devoted to embedded and small IoT devices. There's my contact information. You know, I'm certainly happy to answer any questions as we go. Certainly just simply reach out if you have any questions after the fact. And I thought I would start off real quickly with who is Balena. Most people haven't actually heard of us. We're not a huge organization, about just under 100 or so employees. We are a remote-first organization, so we do have folks all around the world. We do have offices in Seattle, Athens, London, Milan, and Galati in Romania. So there's usually a handful of employees in those cities where offices are located, and the rest of us are distributed around the world. You may actually have stumbled upon us, though, if you've ever used Etcher to flash an SD card or a USB stick. So, you know, common use case, you're flashing Ubuntu to a USB drive, and you know, I get it. You could certainly use the DD command, but most folks use Etcher. So if you've used Etcher, that's one of our open source projects. I'll actually cover that a little bit later. But Etcher doesn't actually pay the bills and keep us in business. What does is Balena Cloud. Balena Cloud, in and of itself, is not an open source project, so I'm not going to cover that one in too much detail, but I'm going to give some background, some context here of what Balena Cloud is, because it actually plays a critical role in all the rest of our open source projects. So Balena Cloud, and what we really truly do at Balena, is build out a fleet management system, a web-based control system for IoT devices. And you have that broken down by applications and devices and workloads, and it gives you the ability to push containers onto target devices like Raspberry Pis, BeagleBones, Jetson Nanos, or, well, we actually support the entire Jetson series. And I'll cover a couple more of the device types later on as well. But the point being is that it gives you a management plane for your fleet of IoT devices, no matter where they are. And a couple of components that go into that are Balena OS and Balena Engine, which we will cover in detail. So I'm going to give you a quick run through of Balena Cloud, just to sort of set that background so that we can talk about the bits and pieces of it later on. But first, I thought we'd better define what we actually mean by fleet management. And, you know, most developers, embedded developers, IoT developers, I see more and more edge being used as the terminology here, or AIoT. But no matter what, if you have a Raspberry Pi or a BeagleBone or a Jetson or Toradex makes fantastic hardware, Verisight, it doesn't matter what the device is, but it's on your desk. You are able to hook up a keyboard, a mouse, a monitor to it, hook up to Serial to get the UART, to get the console off of it. You can interact and develop and, do your code, do your coding right there easily, because it's within arm's reach. But what happens then after you go from prototyping on one device to what we call production? And production is, you have a fleet of devices. They're all over the world, or maybe they're geographically located within a city, if it's, smart mobility like scooters or things like that. Or maybe the devices are in warehouses and distribution centers. Maybe the devices are not actually all the same. Maybe you have a mixed fleet, is what we call this. Different devices have different capabilities. If you're doing some edge AI work, perhaps you have different types of Jetsons depending upon the use case. Point being is, once the devices are no longer on your desk, you need a way to continue to push your applications and continue to develop and maintain those devices. And short of getting on an airplane, doing it through a management platform is probably the better solution. So I'll give you a couple of quick screenshots. Here is what it looks like in practice. You can see all your devices are listed out. You can see in this one, I've got most of them online, but I see one of those Raspberry Pi 3s is offline. When you drill into a device, you can see the device's details, the logs that are streaming off of the device. You can open up a terminal and SSH session to the device, and you can see what containers and what workload is running on the device. And you get a little map here to show you, where the devices are geographically located, and it makes it easy to continue to interact with your devices, again, no matter where they are, so long as they have internet connectivity. They do need to obviously be able to communicate, so whether that's Wi-Fi, Ethernet, or if they're off the grid and on cellular, that works too. So with that background out of the way of the product we're building, we can then start to dive in a bit to some of the architecture, what goes into it, and cover what parts of this are actually open source. The first thing to talk about, we'll do a deeper dive in a few minutes, but the first thing to talk about is Balena OS. And Balena OS is the OS that we build. It's based upon Yocto. Upstream is the Yocto layers. And it's obviously optimized for embedded devices and IoT usage. So it's minimal by design. That of course means lower RAM and resource requirements. We do include redundant rootfs partitions. There's an A side and a B side. So if you are doing an operating system update and things don't go quite according to plans, the device will automatically roll back or fall back to that previous partition. More tolerant of power loss or minimized SD card writes. The trick there is actually that we, by default, log to RAM to minimize the wear and tear on the SD cards. We can cover that a little bit later in the session as well, but we know obviously that SD cards are not the most reliable medium of storage. So we try to lower the impact as best we can. But the point being here is that we are not using, or when customers are going out and deploying devices, we do not expect them to deploy Raspbian or the Ubuntu distribution provided by NVIDIA, which is called Jetpack, or any of the other OSs. We actually roll our own, and it's baked into the process of deploying a device. The next piece of it is the container engine. Everything in the Balena world is intended to be, or I should say, the applications that customers are running are intended to be containerized and pushed to the devices in the via a Docker file. So, built into the OS, we provide a container engine, a container runtime. We call it Balena Engine. It's based upon Moby, which is the open source contribution from Docker. Now, similar to Balena OS, it is, in this scenario, stripped down a bit from the full Docker or Moby project. You know, Docker was born with the intention of being used in a data center, and it has some extra features and capabilities that, quite honestly, just are not needed in the IoT use case. So similarly here, what we're doing is literally stripping it down to make it a lighter weight implementation. There's a couple other features thrown in here with the Delta pools to save on bandwidth and the fault tolerance. The Delta pools is a big one, though, especially as we see more customers doing edge AI or robotics or things like that. These container sizes are actually quite large. Some of the NVIDIA containers are 10, 15, 20 gigs in size. If you have an IoT device sitting out far, far off the grid, connected over cellular, and that cellular is only 2G or 3G, you're going to be waiting a really, really long time to download a 20 gig container. But what we actually do instead is when a customer pushes a new container, a release is what we call that, we do a quick comparison of what container is currently running on the device versus that new one, do a delta, a diff on those two, and then only push what has changed down to the device. So that can save significantly on cellular costs. And let's go through just a few more bits and pieces to interact with the devices and actually push those containers. We have a little bit of tooling here called the Balena CLI, and that's what allows you to interact with the fleet, build your Docker files, and push them onto the devices, you know, again, no matter where they're located. We sort of already showed that, but then, you know, in this next one here, you can see at the bottom left, this device has 4 containers, Grafana, Influx, MQTT, and a sensor block. And it shows the progress of them being downloaded by the device. So let me take a quick pause here and check for any questions. Let me take a look over in... There's a Slack channel. Let me take a glance through there. Not seeing any questions. And then there's also the chat window here in the platform, and I'm not seeing any there either. So I think we're good for the moment. All right, let me come back over to the deck. And I also noticed, just incidentally, I'm looking at the clock. I noticed that we got scheduled for an hour. I had actually only targeted a half an hour for this talk. So that's good that we have a little bit of extra time, but I might get you out of here a few minutes early. So you may have a couple minutes coming back to you. Let me get screen share back up. And we can now with that background knowledge all out of the way, we can really dive into what I wanted to cover, which is our open source contributions. So the first one, like I covered briefly thus far, is Balena OS. Balena OS, as mentioned, is based upon Yocto Linux. Now, Yocto Linux, of course, is open source. So naturally, the right thing for us to do here is to also provide Balena OS as open source. So you can take Balena OS, you can build it from source, which is in GitHub, and we'll get to that in a moment, or we provide ready-made, pre-built OSs for devices. Currently, we support, at last check, it was 69 different device types. So if we happen to build one for the hardware that you're using, you can actually go and download it, flash it to the SD card, and power on your device, and you will just simply be brought to you will be running a minimal OS with a container runtime. This is a standalone version of the OS. It does not connect to Balena Cloud. It does not have anything that hooks it up to our systems in any way. It is just simply a minimum OS with a container runtime. You can see here, I've got a screenshot of just the top half of the devices that we currently support. You know, you might recognize a few of these. The Tinker boards are in there from Asus. There's a couple Beagle boards, like I said, in there. There's one or two. There's one Banana Pi that is shown there. I know further down the list, there are some more enterprise-grade boards that we support. So those CTI devices, CompuLab, Digi, you know, they produce some more enterprise-grade hardware than your typical Raspberry Pis. You can see the Coral Dev board is on there. Further down the list is all of the Jetson devices. We actually support the entire Jetson line. So that includes the Nano, the TX2, and there's a second variant of the TX2 that just got released, which is the TX2NX. That one is in the pipeline and coming soon. There's the Xavier NX and the Xavier AGX. So you can kind of, you know, target depending upon just how much horsepower you need. But the point being is all of these are, like I said, ready to go, pre-built, or you can just go to GitHub, and I'll provide all the links. I'll drop them in. Well, actually, now that I think about it, I'll just upload the slide deck. I noticed the ability to upload the slide deck just when I was getting ready to launch the session, and that wasn't there previously. So I'll get it uploaded. But you know, suffice to say, over in our GitHub repo are all of the various board types. So you can see here, Balena Upboard, Balena Raspberry Pi, Balena Jetson, Balena Intel, Balena FSL ARM is Freescale for all the Freescale IMX6 and IMX8 devices. And you can kind of poke your head into them. Here's the Allwinner repo. It looks pretty much like any other Yocto repo, with one exception being that top one, Meta-Balena, and that includes some of the Balena tooling, like the engine, the container runtime. You can begin to poke around within the layers themselves. You can see here are the machine conf files for some Jetson devices that are supported. And, you know, you can use some tooling that we have in place to build from source if you want. Now, a Yocto build typically takes a couple hours. So you can sort of choose whether you want to, just use the pre-built one, or if you have customizations to make, build from source. The other talking point here would be it's pretty easy to add support for your own boards. So like I said, we have 69 discrete devices that we have built for. Some of those we build just simply because we know we need to. So like the Raspberry Pi series, right? It's so common, it's everywhere. People ask about them. We know we need to build for the entire Pi series. That includes the Zero, the original Raspberry Pi, the Pi 2, 3, and 4. The Jetson devices similarly. We know people, individual developers, are going to ask about them, so we just build them, and that's that. Some of these others, and you can kind of see them on the screen here, are more customer driven. So a Photon is a CTI board, the Spacely, N310, JN30B, the Floyd Nano, the CTI Rogue. These are usually done at the request of a customer, but nothing is actually stopping end users, again, all being open source, from cloning and then adding support for more boards. And there's actually quite a few that end up being community contributions, especially back in that Allwinner repo. There's a bunch of them in there that are just community contributed. You can take an existing repo, Allwinner's probably a good example, and most of those devices in there use the mainline kernel. So you can pretty easily go into those, build out a new machine conf file for your target device, define the device tree to use, define the U-boot configuration to use, run the build, and come away pretty quickly with a custom OS for a device type that we actually don't have anything ready-made for. And if you do that, by all means, please submit the pull request. But it's it's not too difficult. And then even if you do need to start from scratch, if it's a chipset, an SoC that we don't currently have anything for, I guess AM Logic comes to mind. We don't have any AM Logic boards currently in here. But, you can, again, create the meta layer, pull in, you can see in the Allwinner one, it's meta-sunc. Pull in what you need and get it built in relatively short order. And there's documentation on our website for that, and how to go through the process and what is needed. So that covers, I think, most of the OS talking points. Let's see. Let me do another check for questions. Pierre, thank you. I see you said Slack-4. Let me take a look over in track 4. Nothing there. All right. So either I am covering it in very thorough detail. No, we do have one in here. Go ahead, Pierre. I see it coming in right now. We'll take a moment to pause here. What is not open source in Balena? Well, that's a great question. Very little is not open source. The only thing that is not open source is, I don't know if you caught the very, very beginning of the talk. I showed, we started off by doing a background context of Balena Cloud. That web interface to control those devices, that GUI, is not open source. That really is our only proprietary. That is what we provide to customers in exchange for, various subscription plans, that paid service. is really the only thing that is not open source. So that dashboard with the ability to interact with the devices is the only thing that is not available. Everything else, all the components that go into making it work, are open source. So, we just covered the first one. Let me come back to, oops, turned off the screen share. Well, here I am. So let me come back to the deck, and we'll go to the second piece of the puzzle then, which I said earlier is the engine. And the engine is the container runtime. So now that we've got the OS covered in detail, and again, you can go and use it for your own projects right now. If we have time at the end, I'll talk about a couple of use cases. The second piece is the container runtime. So you can see here, similar to the OS in theory, we build one ready-made that can be installed on your devices, your OS of choice, or you can go to GitHub, clone it, and build it yourself. So you can see here, I kind of talked about this in the beginning, that it's a slimmed down runtime, slimmed down on purpose, because some of these devices only have, 512 megs of RAM. It's not, when you're talking about IoT devices, you don't have the luxury always of reliable power, reliable connectivity, and tons of resources, RAM and disk space, like servers. Let's go to the next one here. Here it is sitting in GitHub. You can see, just like any other GitHub project, everything is in here. You can clone it, pull it down, and build it. Or, as I mentioned a moment ago, like the OS, we do in fact provide ready-made releases. If you don't feel like going through the build process, you can just pull down one of ours that we've already done. And it's for both x86, ARM v8, and I want to say there might be an ARM v6 build as well. The text on there is a little bit small to see, but the reason for that one is the Raspberry Pi Zero, which is a v6 device. And you can pull it in with curl, or you can just download straight from the website. And you can see we have 1,818 contributors. But I told you earlier that there's only 100 employees at Balena. So, you can tell it's a fork straight off of the Moby branch, because we certainly do not have 1,800 employees here. So, just like talking about the OS, we take from upstream. We want to make sure that we are giving back. We're not going to take from upstream and then close source something. That's not the right thing to do. So you can, you can git clone, you can modify, you can build. If, there's changes or fixes or bugs or things you come across or improvements, by all means, PR them right back. We're happy to take them. The next one on the list, it's a little bit of a change of pace, and we covered it in the beginning, but Etcher. Etcher's open source. Etcher is used literally millions of times per month to flash SD cards or USB sticks. And so if you've used it before, it's pretty simple. You choose your image, whether that's a zip file, a .img, a .iso. Choose your target device, and you hit flash, and it'll write the image to the card. So, if you're a habitual Raspberry Pi tinkerer and write a lot of SD cards, you might have come across it. Etcher, like I said, is actually really, really popular. It's got 20,000 stars and 1.4 thousand forks. And it's used, like I said, widely, literally millions of times per month. It also sits in GitHub, as all of our other projects do. You can take it, you can build it yourself. It's an Electron app. And we see a lot of folks out in the community take it and modify it for their own purposes. And that's totally fine. That's what open source is all about, right? So here's an example of one. This is a project. This is actually a really neat project that does sort of like a surveillance or like home video camera system by the name of Kerberos. Kerberos has taken Etcher and skinned it, themed it for their own purposes. And, you know, you can see it says select KIOS, what they call the Kerberos operating system. Another one that you might be pretty familiar with is the Pine team. Pine 64 has a version of this out there. They call it the Pine 64 installer. So, you know, Pine, actually, they have a new board coming out as well based on the RK3566 or 8, I can't recall. But, you know, if you have the Pine, the original Pine 64s, they have the Rock Pro, there's the Rock 64 as well. They provide this. Choose an OS, connect the drive, and flash. So you can see projects out there making use of it. Let me pause there again because we've now covered the engine and Etcher. And let's do a quick check for any questions. Let me head over to Slack. Nothing there. And in chat here, nope, nothing. So I guess we're good. All right. Next item on the agenda, open source. So this one gets interesting. This one here is called OpenBalena. And OpenBalena is, as you can see, open source software to manage connected IoT devices. Well, now wait a minute. I started this talk off by showing you Balena Cloud and how it allows you to manage those fleets of devices and, you know, interact with, push containers to, et cetera, et cetera. And like I said, when I answered that question earlier from Pierre, I said that that was not open source. That's the only piece that's not open source. So hang on a minute then. What is this? So OpenBalena is a standalone, open source, command line only, CLI driven version of Balena Cloud. Almost, there's a few bits and pieces that are inherently tied to the Balena Cloud web-based dashboard. But almost all of the bits and pieces of Balena Cloud provided into a self-hosted application. You install it on a server, so you can spin up a VM, could be bare metal, you know, you can run it on your own network or on a cloud server somewhere. And it allows you to do all of the same things that Balena Cloud gives you the ability to do, which is provision your devices, connect to those devices, again, no matter where those devices are, push your containers onto them in one fell swoop. When you push containers, you're pushing to the whole fleet of devices. And you can segment those workloads, you know, or segment the devices out. But And devices can actually move between OpenBalena and Balena Cloud. So, really, back to Pierre's question, the only thing not open source is that GUI that we've built, the web-based GUI. But the core functionality is actually available in OpenBalena. So you can, in fact, do your own IoT device management, CLI only. It's not that difficult, quite honestly, because the tooling is still all the same. So I showed a screenshot way back in the beginning of what I said was the Balena CLI, and it allows you to interact with the devices, do your pushes, do your builds. Same CLI is used here to interact with your OpenBalena server. And you can, in fact, deploy out at scale your IoT fleet. There's also, because all the API stuff is the same, there are some open source community-led projects to build some dashboards for OpenBalena. Don't have the link in front of me, but I can provide it. I can dump it into the slide deck and then provide the slide deck. I'll upload the slide deck to the session anyway. But point being, to be fair, it's not total parity one-to-one in the open source community contributed dashboard versus what we have built for the Balena Cloud dashboard. It's not really a fair comparison to make anyway, but there is some minimal ability to interact with the devices using a community-led project to provide a GUI for OpenBalena. So even if someone, from a vendor lock-in perspective, didn't want to go down the Balena Cloud, our proprietary version of the Balena Cloud, GUI, they can always just run their own. And again, they can even move devices between OpenBalena or Balena Cloud. So even if things just, didn't quite work out the way that they wanted, hopefully we're taking care of our customers to the best of our abilities. But if for some reason they, wanted to migrate off and no longer be, quote unquote, tied to Balena Cloud, they can run their own. And so just like I said about all the other projects, oops, went one too far. It's available on GitHub. There's documentation. You can run the build, install it on your server, and away you go. So hopefully that gives you an overview there of the OpenBalena project. And then the last thing to cover, let me look back at the clock again. Like I said earlier, we're ahead of time. That's always a good thing. But the last thing I want to cover is more of a project or more of a team within Balena devoted to building, as you can see here, ready-made projects, examples, and sample code and containers. And again, everything that these guys build is open source. So this gives you some building blocks, some starting points for your IoT projects, whether you use Balena to deploy them or not. So the Balena Labs team, like you can see here, they build all kinds of neat little things. Specifically, I'm using the word because IoT, such as environmental monitor. There are kiosk and digital signage projects. There's some LoRa gateway projects. I think the Helium project is one they're working on as well right now. there's a lot of audio and camera and streaming building blocks. There are a few AI projects and computer vision. Open Data Cam is one application that we've containerized and built for deployments. Just recently, I myself put a couple of ROS repos up into GitHub to help folks get started with the installation of ROS on or in a container that can be pushed to devices. And again, all of these can be, used in your projects. Let's go to the next one here. There are a couple of the repos there, same as before. I'll get the deck uploaded so you can just grab those. A couple of screenshots. So a lot of these, we do thorough documentation on. These have big tutorials on how to deploy them, thorough blog posts that go through the builds from start to finish. And, we have them branded, like you can see here, Balena Sense, but there's nothing stopping you from taking the project, the code, and implementing it into your own builds. We have the logo on there just for presentation purposes, but once the code itself is not branded in any way, shape, or form, so you can take them and build them into your projects. A couple of last resources are our blog and our forums. The blog is where we put all of our project builds, like I just said a moment ago. The forums are quite active with users building all kinds of things. They're categorized out by, actually, I wonder if I can just click right on this. This is no, I cannot because that's the deck. They're categorized out by the OS, by projects being built, by trying to think what else is in there. I think OpenBalena has its own category in there as well. So you can navigate and kind of browse around, and by all means, if you have questions, put them in there. We monitor them all day, every day. You'll see not only the community replying to folks in there, you'll see Balena employees and engineers replying as well. We treat them similar to our support tickets that roll in. So there's a lot of action and activity occurring in there. I think one last thing for me is a totally shameless plug. Snuck this one in on you, but we also run an IoT happy hour every Friday at 4 p.m. UTC. All kinds of topics covering project builds, covering hardware, covering applications. Tomorrow, for example, like I said a moment ago, we're going to be talking Helium and deploying of Helium hotspots. So come hang out. It's a lot of fun. And that's it. So a couple minutes early, but that's probably a good thing to allow time for questions and Q&A. Let me come back to... There's my contact information one last time.